we have time, let's just do one very quick AP problem that I think you guys know how to do. So let me draw an airplane here. I handed out this question to all of you so you can have the drawings on your piece of paper. Apologies for my horrendous artistic skills, or lack of. So say we have an airplane, and across its wingspan, we have a wire here. Right, so there's a wire here running across the wingspan. And say this airplane is flying in the air, and say that we have a B field going. So the Earth's magnetic B field is pointing this way when the plane happens to be at this location. And I guess the angle here we can call C. So the first question that your sheet asks is, okay, we have a magnetic force, we have a magnetic field here. How does this magnetic force act on the electrons in the wire? Which direction does it push it towards? So, as you all are familiar by now, take your right hand, orient to B, and then curl it towards B. So because this is a side view, our thumb points in. But remember, these are electrons that we're dealing with. So effectively, the magnetic force is pushing these electrons out here. And since this is top view, the electrons are being pushed down. Now, the second, third, and fourth questions ask, what is the magnitude of the electric field? What is the potential difference across the wingspan on this antenna? And which side is the higher potential? That's kind of confusing. I thought we were talking about magnetic fields and not electric fields. Well, as we will come to see in the following few weeks, magnetic fields and electric fields often occur together. They're closely interrelated, which makes E&M fun. But, what's going on here? So, as electrons are being pushed down, this side becomes more negative, and because electrons are leaving this end, this side of the wing becomes what? It becomes more positive, right? Because you have the holes that the electrons are leaving behind. Look, what's happening here? We have a charge separation, and you know that, I guess from your experience with capacitors, that when you have a charge separation, it has electric field also. Aha! So so the magnetic force is pushing the electrons down, but this E field, remember these are electrons, this E field is pushing the electrons back up. So at some point in time, electrons are going to reach equilibrium, and they're not going to be moving up and down anymore. What is that point? You guys saw just a few minutes ago. We're going to set these two forces together, right? So EQ equals QEB, cancel. So the question asks, what's the magnitude of electric field? E is equal to VE. What's V again? V is the velocity of the airplane. V we know. Okay, so we're good. This is the answer to question 2. Question 3 asks, what's the potential difference across the wingspan? The question says that the wingspan here is a length W. So, if you guys remember, hopefully you do. If you don't, no, I'll make speak up. The potential difference is equal to electric field multiplied by the distance across which we're measuring the potential. So the answer to number 3 is EW. And lastly, which end is at a higher potential? Well, you know that electric fields go from high potential to low potential. So this end is at the high potential.